Everyone. My name is Sandari Rushi. I would like to discuss about Earth magnetic field. Magnet. A magnet is any material that attracts iron and materials that contain iron. A magnet is a material or object that produces a magnetic field. Magnetic poles. A magnet has two poles. They are North Pole and South Pole. Magnetic poles that are same repel each other. Magnetic poles that are different but attract each other. Magnetic field. Magnetic field is an invisible space around a magnetic object. This is the object of the magnetic field. A magnetic field is basically used to describe the distribution of magnetic force around a magnetic object. Magnetic fields are created or produced when the electric charge or current moves within the vicinity of the magnet. Earth's magnetic field. This is the picture of the Earth's magnetic field. In this picture, having the two poles, north magnetic pole and south magnetic pole, and assuming that geographic north pole and south geographic south pole. Earth's magnetic field is also known as the geomagnetic field. The magnetic field that extends from our Earth's interior out into space, where it interacts with the solar wind, a stream of charged particles emanating from the sun. Its magnitude at the Earth's surface ranges from 25 to 65 microteslas or 0.25 to 0.65 Gauss. Approximately, it is the field of a magnetic dipole currently tilted to at an angle of about 11 degrees with respect of Earth's rotational axis, as if there were a bar magnet placed at the angle at the center of the Earth. In this picture, there were a bar magnet placed at the angle of the center of the Earth. William Gilbert. The relation between the magnets and the Earth's magnetic field was then discovered in 1600 by William Gilbert, English physicist and physician of Kew, Elizabeth I, or republishing in 1600 of magnetic tellurium from the gate magnet of the Earth. This is the magnetic field. He was the William Gilbert. Characteristics of Earth magnetic field. At any location, the Earth magnetic field can be represented by a three-dimensional vector. A typical procedure for measuring its direction is to use a compass to determine the direction of magnetic north. Its angle relative to north, true north is declination, is mentioned by d or variation. Facing magnetic north, the angle the field makes with the horizontal is the inclination, or we can call as a magnetic dip. The intensity is also we can call as it is symbol as F of the field is proportional to the force it exerts on a magnet. Another common representation is in x, y, and z coordinates. This is the pictures. Geographic north is x and geographic east is y and geographic down is z. Intensity. The intensity of the field is often measured in gas. It is symbol of the gas is capital G, but is generally reported in microteslas with 1 gas is equal to 100 microtesla. This is the picture of the magnetic field total intensity. A nanotesla is also referred as a gamma. The Earth's field ranges between approximately 25 to 65 microteslas and also we can call 0.2 to 0.65 in gases. By comparison, a strong refrigerator magnet has a field of about 10,000 microteslas and we can call it as in 100 gas in declination. Declination is positive for an eastward deviation of the field relative to true north. This is the picture of the magnetic field declination. It can be estimated by comparing the magnetic north-south heading on a compass with the direction of a celestial pole. Maps typically include for information on the declination as an angle or a small diagram showing the relationship between magnetic north and true north. Information on declination for a region can be represented by a chart with axiomatic lines, contour lines with each line representing a fixed declination. Inclination. The inclination is given by an angle that can assume values between minus 90 degrees to plus 90 degrees. In the northern hemisphere, the field points downwards. This is the this is the picture of the magnetic field inclination. It is tied down at the north magnetic pole and rotates upwards as the latitude decreases until it is horizontal at the magnetic equator. It continues to rotate upwards until it is right up at the south magnetic pole. Inclination can be measured with a dip circle. Magnetic field reversals. This is the graphical representation of the magnetic field reversals. The graphic above from the USGS shows the pattern of reversals out to about 4 m by R as determined by potassium argon dating. This set of measurements in opposite directions from the East Pacific rise shows remarkable symmetry and contributes to our picture of plate tectonics. B. Jenner tells the story of U.S. Navy vessels towing sensitive magnetometers across the ocean floor in the 1950s. As a part of the Cold War strategy of finding ways of detecting Soviet submarines and concealing theirs. When the normal magnetic field of the Earth was subtracted, there were variations on the order of 10% from the magnetism of the seafloor rocks, which showed reversals of the direction. This is the normal and magnetic polarity symbol. This is the mid-oceanic ridge. This is the lithospheres. The zone of the magma injection cooling and locking in the magnetic polarity. The red mark was calculated magnetic profile assuming a seafloor spreading. The blue color design tells that observed magnetic profile from oceanographic survey. Thank you.